This is the first video in Module 4. And in Module 4, we mostly look at properties of quadrilaterals. Now, to begin that study, I want to build some tools that we can use throughout all of Module 4. And so in this video, we're talking about how slopes of perpendicular lines are related. And we're also talking about how to find distance and slope in the coordinate plane. Let's get started. In order to look at the slopes of perpendicular lines and how they're related, let's go through this activity that shows what happens, but also will show why it happens. We'll start by graphing 2 points, point O, which for simplicity, I've picked to be 0, 0. And the point A, I picked just some random point in the first quadrant, and I picked 4, 7. That's point A. We'll look at segment OA and focus on that segment. Now I will rotate segment OA 90 degrees counterclockwise around the origin, around 0, 0. That's just for simplicity, to make this to kind of emphasize what's going to happen. So point O is super simple. It just stays there, right? O prime is the same as O because it's at the center of the rotation. Point A, however, does move. And to get from the center of dilation to point A, I have to go to the right 4 and then go up 7. Okay? And also to graph, now as I rotate these arrows 90 degrees counterclockwise, let's get a quick compass of what that looks like. Counterclockwise is going the opposite way from how a clock goes. So if I was going right, I'm now going up. If I was going up, now I'm going left. So I'm going to go up 4 and left 7. Up 4 and left 7. And this point right here is A prime. So this right here is the rotation of OA 90 degrees counterclockwise. Okay, now because I rotated this shape 90 degrees counterclockwise, that means that the angle formed here is a 90-degree angle. Okay, that's what happens as you rotate things. You create the same angle of your angle of rotation. Okay, now we're focused on the slopes of OA and OA prime. The slope of OA is a rise of 7 and a run of 4. Okay? And the slope of OA prime is a dropping 4, so going down 4 and then running a positive 7. Okay? So the question is, how do these slopes compare, right? How does this right here, 4/7, and how does 7/4 and negative 4/7 compare? Well, there are two things that happen. Okay? The first and most obvious is they are reciprocals of each other, meaning I've taken the fraction and I flipped it over. Okay? They're reciprocals of each other. But not just that, the signs are also different. This is a negative and this one's a positive. They are negative reciprocals of each other. Okay, that's the first thing that happens. The second thing is equivalent to it, but another way of thinking about the same thing, if you multiplied 7/4 and negative 4/7, you would get a negative 28 over 28, which equals negative 1. Okay, these two things happen. We get negative reciprocals whenever we have lines that are perpendicular. Okay, and the second thing, if you took their slopes and multiplied them, then the product would be negative 1. So the thing I like about this activity is that it also shows why this happens. Okay, if you point out over here, these arrows and how they turn is really important. Okay, the reason why this happens is because my run of 4 becomes my rise. right? The run becomes the rise, and the rise of 7 becomes a run of 7. Okay, so the run becomes a rise, and the rise becomes a run. That's how the reciprocal happens. Okay, the second thing is that in this one on the left, as I drew it here, it went from positive to positive. Okay, but for the other coordinate, for the 7, it went from a positive in the y direction to a negative in the x direction. And that will always happen because to get a 90-degree angle, one must be negative and one must be positive. Okay, so you'll always have one of them that'll switch from negative to positive or positive to negative as the direction for the slope goes. Okay, so that's what happens and why it happens. The second topic I want to discuss in this video is about the distance formula and how to find distance between points. Okay, and this is the simplest way that I know how to do it. It comes from the Pythagorean theorem. So if I have a right triangle, I know that a squared plus b squared is c squared. A squared plus b squared is c squared. Okay, now on the coordinate plane, what I want to find, if I draw in a right triangle here, then the side that I want to find the length of is always the hypotenuse. So what I care the most about for what I'm doing right now is the length of the hypotenuse. Okay, and that is always going to be c. So if I solve this equation, the Pythagorean theorem for c, I'll take the square root of both sides. And I find that c is the square root of a squared plus b squared from the Pythagorean theorem. So what that means, if I find this length down here, 1, 2, 3, 4, 5, 6, and this length here, 1, 2, 3, 4, 5, 6, 7, then I can simply find the length of this hypotenuse by doing the square root of 6 squared, this horizontal distance, plus 7 squared, the vertical distance. And I get, if I plug that into a calculator, I get about 9.2, rounding to the nearest tenth. Okay, here's one more example of that. If I draw this down, it doesn't matter if you go above it or below it. Okay, this height is 1. The width is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so this length here is the square root of 9 squared plus 1 squared. Now, I always do horizontal squared plus vertical squared because the distance formula is written in that form, but mathematically it doesn't really matter because addition is commutative. Okay. Oh, sorry. The square root of 9 squared plus 1 squared is 9.1. Okay, round to the nearest tenth. That's the easiest way to find lengths of segments in the coordinate plane. The last idea in this video is about how to find slopes. Okay, and this is as simple as the slope is the rise over the run. And I always think about these as far as the direction goes. And I always go from the left point to the right point. Okay, so to get from the left point to the right point, I'm going to go, let's say, just go down first. You could go, you do a run first, but I'm going to go down, and that's in the negative y direction, 3. So my rise here is negative 3, and my run is in the x direction, positive. It's a positive 2, so my run is 2, and I get a slope of negative 3 halves. And for this one, it's actually very similar, and I should have picked a different one, but it's just what I picked. The slope here from the left point to the right point, I'm going to run first positive 2 and rise over run. So that 2 is in the denominator, and the rise is 3 in the numerator. So I have 3 halves as that slope. Okay, but you can just find the rise, the run. The important thing to point out about slope is that the signs do matter. You have to think through, am I going in the positive x or negative x, positive y or negative y direction? All right, this video was about slopes of perpendicular lines. You get negative reciprocals and why that happens, and also looking at distance and slope in the coordinate plane. Thank you for watching.